Welcome to Olympiad Math for Year 3. This is Lesson 3, we'll learn how to fill in the operation symbols. Here are two methods you need to know before our examples. Please pause the video and read this page carefully. Let's look at example 1. Insert appropriate operation symbols, plus, minus, times, divided by, and optionally use parentheses, to make the following equation valid. Let us analyze step by step. First, start from the result. The final result is 0, and the last number is 1. If we look backward, subtracting 1 from the preceding numbers is a clear way to achieve 0. Second, consider alternative perspectives. If we start from the first number 3, subtracting 3 from the combined value of the remaining numbers also results in 0. Finally, let's look at the relationship between 2 and 1. They should be added together to make their sum suitable for subtraction, and parentheses are required to group 2 and 1 before subtracting. When solving these problems, the trial and error method is essential. Begin with the result, test different operations, and adjust as necessary until the equation is valid. Example 2. Insert appropriate operation symbols, plus, minus, times, divided by to make the following equation valid. First, using the method from the previous example, we analyze the equation starting from the first number. Start with the initial number, from the number 3, subtracting 2 yields 1. Second, determine the relationship for 2, the number 2 can be obtained through 2 divided by 1. Alternatively, 2 times 1 also gives 2. Finally, fill in the operation symbols. Based on the above reasoning, the equation can be completed in 2 ways. This example can be approached either by starting from the result or the initial number 3, as demonstrated. Beyond these 2 solutions, you are encouraged to explore other combinations of operations to solve the problem. Example 3. Insert appropriate operation symbols, plus, minus, times, divided by, and optionally use parentheses, to make the following equation valid. First, using the approach of working backward from the result, focus on the last number 5. If the last number 5 is preceded by a plus sign, the remaining 4 5s must combine to form 5. Second, continue working backward. If the second to last 5 is also preceded by a plus, then the remaining 3 5s must combine to form 0. Third, to achieve 0 with the first 3 5s, we have the following 3 cases. Alternative operations. Explore other possible combinations where the last 5 is not preceded by a plus sign. The following valid solutions can also be constructed. This problem is best solved using the approach of working step by step from the last number to the first. By testing different operations and combinations systematically, you can piece together valid solutions. Feel free to try other methods to explore additional possibilities. Example 4. Insert appropriate operation symbols, plus, minus, times, divided by, and optionally use parentheses, to make the following equation valid. To solve this, consider 2 key observations. First, the difference between 2 9s is 0. Second, any number multiplied by 0 results in 0. Using these principles, valid solutions can be constructed. Following are examples. This problem highlights the use of logical deduction and multiplication properties. By starting with the difference 9 minus 9 equals 0 and leveraging the fact that 0 multiplied by any value equals 0, the solution becomes straightforward. Example 5. Insert appropriate operation symbols, plus, minus, times, divided by between 8 eighths to make the result equal 88. We aim to manipulate the eighths to achieve the target result of 88. A helpful approach is to first focus on forming smaller groups or partial results that approach 88. First, group some eighths to form intermediate results. For example, 8 times 8 equals 64, leaving a difference of 24 to reach 88. Second, construct an equation using addition and subtraction, using 8 plus 8 plus 8 plus open parenthesis 8 minus 8 close parenthesis times 8 equals 24, we can combine this with 8 times 8 equals 64. Third, alternative interpretation of the problem. If the problem allows numbers to combine without explicit operators, then some eighths can form multi-digit numbers. For instance, 88 plus 888 minus 888 equals 88. Example 6, insert the four operators, plus, minus, times, divided by into the circles below, using each operator exactly once, and fill the squares with appropriate integers such that both equations are valid. What numbers should go in the squares? First, focus on the first equation. To achieve 100, consider how the numbers 9, 13, and 7 can be combined. Thus, the first equation is 9 plus 13 times 7 equals 100. Second, remaining operators for the second equation, with divided by and minus left, you can now attempt to complete the second equation. Can you figure out the correct operators and the value for the square? Start with the first equation by thinking of how to achieve the result of 100. After completing it, use the remaining operators to solve the second equation. Here are the practice problems for today. Thank you for watching and hope you enjoy your math today.